Hello, everyone. Ms. Han is with you. The Gerasim channel is the world of all-terrain vehicles. Today I came to Zhukoff Garage in order to tell you about the new development of Beetle's Garage, the all-terrain vehicle Bro Electro. As a matter of fact, this car is standing here. Today we will test it, check its capabilities. True, today we have winter, everything is hard and white, but we will try to find some kind of slope or maybe break the ice. In general, let's go, let's see what this car can do. So, let's see that there are differences inside the car, they are insignificant, nevertheless they are there.
So,
the first thing that catches your eye is the space between the driver and the passenger. It's convenient. Then we have a row of seats, a sofa, quite comfortable. Here, despite the fact that the chair is pushed back to the end, there is a place with my knees, I do not rest against it. As well as standard equipment, we have fasteners for cargo, here is a wet rail, they are present on both sides. Molly system shutters. Here we have double glazing on the side windows, sliding panes, double glazing here, too, and the front side windows also have double glazing, should not sweat. A steering wheel with all the necessary information, speed, voltage, temperature of the controllers, the direction of movement of the all-terrain vehicle, front reverse gear. Here we have two gas and brake pedals. This is probably one of the differences in everything that concerns the interior of the car. Well, now I'm going to try to drive an all-terrain vehicle and see for yourself what will happen. Let's go. I will be assisted in the management by a voiceover. This is Yevgeny, the permanent head of the Zhukoff Garage.
in order to make the start of the movement, everything is very simple, as in a car with an automatic transmission. We squeeze the brake and turn on the speed lever forward. The direction arrow is displayed on the monitor. Depending on the selected lever position, we look where we are going. Now we have an arrow forward. I want to draw your attention to the fact that as soon as we turned on the speed with you, our steering wheel became active. The car can rotate around its axis without pressing the gas. That is, if we need to align somewhere or set our turn to move forward, we do it without gas. Misha can try to work the steering wheel smoothly in one direction, in the other direction. We are now observing that the all-terrain vehicle is starting to move around its axis, called the Rameness counterattack. We have now demonstrated how the steering wheel works in place when it is active. Now, Misha, you start moving by gently pressing on the gas.
So.
And straighten, choose the direction of the steering wheel. It's like driving a car.
The acceleration, I'll tell you, is just impressive. It is very precisely controlled, accelerates, and I must say, but my car does not accelerate as much as he does. From the place blows only on the way. Well, I'm sorry for my verbal, meager emotions, this is something. So. Now,
The movement is carried out behind two engines, which gives it such a friskiness. Two Japanese electric motors stand with a total capacity of 210 horsepower. Accordingly, such a speed is given to him by such a power plant. Each engine stands on its own board, which allows it to perform a counterattack or a smooth turn. That is, the moment of turning we have all four wheels rowing, just one side does it slowly than the other. That is, the moment is present on all four wheels.
But this will give him a great advantage on liquid peat and other poorly bearing soils, because turning on an all-terrain vehicle with a manual transmission implies that one side turns into an anchor in fact. So, well, we have already had a forward movement, let's try a backward movement. To secure it, there are two side mirror screens and a central one. This is a standard option for cars.
So,
we pressed the brake, an arrow appeared, saying that we will have a stern forward movement. Well, actually we will try. This is very unusual. Lack of diesel operation.
We have a limited speed for backward movement specifically so that no emergency situations occur. Therefore, moving backward somewhere well in the region of 10 km per hour is the maximum speed that you can move backwards, restricted forcibly and programmatically. With the rear speed, everything is clear. Let's go for a ride on the field, let's see how you will go forward. You will feel the steering wheel, how the rover behaves in general, how it responds to the steering wheel. You will share your impressions, and then we will go to more difficult areas. You'll see how he behaves already, we can say, in the real conditions of an all-terrain vehicle.
So, well, to move forward, we need to press the brake pedal, switch the lever to drive forward mode and actually start moving. The all-terrain vehicle is ready for a jerk throw. Let's try what he can on his limits. Yes, I'll tell you, it's something. It steers very precisely, reacts to the steering wheel, so we need to think more carefully. So, steers very smoothly, accurately. I would even say you can do ballet. Everything that needs to be done on a narrow road in the forest, somewhere between some stumps or inconvenient exits. That's it. Fantastic.
Yes, I would like to add that the more you turn the steering wheel, the faster the turn on the spot is carried out. The less the steering wheel turns, the angle of the steering wheel, you can pay attention. It's slowly starting to break down, slowly. If I turn the steering wheel further, the speed of rotation, but it is also limited, so that it does not work out when an emergency situation occurs. People inside the rover did not hang out and did not get any injuries.
For those with a weak vestibular apparatus, I do not recommend indulging, because, well, there will be seasickness. Let's go see some slides, try to break the ice, but if we can get out of there. What did I experience from the management? The car rolls exceptionally accurately. Now I will turn on the drive. A small movement of the steering wheel, literally with a finger the car performs turns. If we compare it with lever control, then it seems to me that it will be even easier in terms of labor costs.
In fact, in order to make a certain maneuver, you do not need to make any effort. Those who rode on levers or on the steering wheel there, as we did. We are used to the fact that in order for your all-terrain vehicle to turn in one direction or another, you first have a slight pressure. This is when the clutch is released by hydraulics or electrics, and only then you slow it down by applying certain efforts. It all depends on the design. Electronics does it all for you here. Moreover, the steering wheel is designed so that it has feedback. Now if Misha tries to turn one way or the other, he will feel that he is resisting. By doing this, we can understand what is under your wheels at the moment. That is, it clings to the ground or it clings to the snow, or it slips on the ice. What is the load on the all-terrain vehicle at the moment? It is hard for it or not. Well, as if foolishly, you can break everything, if you do not pay attention to how difficult it is for technology in certain conditions. Therefore, with us, we feel that under the wheels of the car. And the same thing happens at the moment of movement. I think that Misha didn't really have time to feel it right now, but when we drive on the road, on a tougher road, we feel, relatively speaking, lamellas on rubber. That is, the steering wheel gives us feedback. This is also, let's say, our own development. For a very long time we picked up the steering wheel, adjusted it, prescribed brains so that it, together with the engines, with the controllers, formed one single chain, a living organism. So this is really the future. I don't want to say big words there, but it is. And I think that the electric drive is combined with a good battery or with a good generator. And this is really the future.
On my own behalf, I want to add that I really liked the management of the all-terrain vehicle. I completely agree with Eugene's words that electric drive is the future. Will it be either just a car on a battery or it will be a car with a generator or a hybrid diesel generator? Battery car is not even better, but more efficient control of the car, in my opinion, is difficult to come up with at the moment of history, because well, what can, and what can still work out like this? Tell me what? Unbelievable.
I suggest we try it in tougher conditions, so let's go to the forest now. In the hill you will see how the all-terrain vehicle behaves, what kind of handling it has on a forest road, between trees, ascents, descents, then where it is mainly used everywhere.
Well, yes, then we're all on the field, we're revving it all up. Show the way where to go. So guys, we have a small descent in front of us. I'll try to stop right in the middle of the descent, carefully. Moreover, the ground is frozen, it's slippery enough to stay on such a slope. Well, I must say, it's difficult. Now we are gradually, carefully, I'm getting used to this miracle. Well, here we are practically standing, here we are all standing on the slope, stopped. And we overcome the rise. On the rise, we get up, I release the gas pedal, the car got up. So, well, I see that now we have a load on the engine. The display is visible. We stand due to the magnetic field in the engines that holds. We're all not moving. Imagine such a situation on a manual transmission. I press the gas pedal, do not touch the steering wheel, we continue to move. The rise, I must say, is at least 30 degrees at the end, the exit. So, what I want to say about the management of this device. I don't have much experience, about 20 minutes, and nevertheless I want to tell you guys that this is a new level. The machine can measure literally millimeters, centimeters, that is, it is possible to repeat this on a manual transmission, but it will require some effort. Here it turns out everything is easy and at ease. Frankly, I don't want to get out from behind the wheel. I want to go somewhere, steer between some trees to get very nice, very nice. We can say that this is similar to how we play cars in childhood. That is, we take the typewriter in our hand and drive it between obstacles, carefully, exactly as we want. That's exactly what it looks like. Very precise, very smooth and powerful control is obeyed from these. Amazing, amazing, just amazing.
Well, I want to add a little bit then. Indeed, here is the first impression completely tells its own. And indeed, he correctly picked up a comparison with a child's car in control, when we put it forward, backward with our hands, turn it to a really very accurate description of how the all-terrain vehicle behaves. How is it all? That is, I will try to tell you a little bit how we did it, how we achieved this effect. In addition to the fact that there are two electric motors, each electric motor is controlled by its own brains. Let's call it a controller. We had to develop the controllers ourselves. Because not a single purchased controller. We used both Chinese controllers and controllers from Nissan Leaf, native controllers from the engine. That is, none of these controllers allows you to make a number of settings there so that the all-terrain vehicle is controlled exactly the way we need, the way we wanted. So we had to create our own controllers. That is, it is completely from scratch developed software, completely from scratch developed hardware. That is, we created a computer absolutely from scratch. We tested it in laboratories, loaded it. Now our controller can safely withstand 800 amps of load. His limit is 1200. That is, today, everywhere we rode, and what is now worth the load, it is 450 amperes we have on an all-terrain vehicle. That is, we can change the degree of load on the steering wheel, or let's call it the power consumption on each of the engines. And now we are driving with a capacity of around 50%. Accordingly, for more severe conditions, we can disclose this capacity. This is done forcibly for each owner. We tell you how to enter the menu, how to change these settings, what parameters to set so that everyone is comfortable and safe. That's why the controllers were created, tested, and a number of settings were made there, about 1,000 parameters changed during driving and while driving. That is, two controllers work with each other and remove about 1,000 parameters that were programmed and exposed during the tests. Then there was the complexity, the fact that it was necessary to manage these controllers. Here I had to develop a steering wheel, again with my own brains. In order for him to control the controller exactly the way we need it. That is, at a certain angle of rotation of the controller, at a certain speed, the engine performs a certain work. And as soon as our speed or angle of rotation changes, all the parameters of one or the second engine immediately change. So I had to create a steering wheel, controllers, and a monitor that displays all this information that can be changed, but basically everything. All settings are sewn deep enough and limited. We have now come to the ideal that we have. And speed limits, and power limits, and a number of security systems that turn off your car, well, that is, they go into error and calmly reboot. That is, they do not allow you to burn, blow up or spoil the all-terrain vehicle in certain conditions. Because, for example, on a diesel car, the electric motor can be overheated, the controller can be overheated if there are colossal currents, colossal resistance. There was also an issue with recovery. That is, no controller could turn on the recovery from two engines, power it in parallel. That is, we have also solved this issue. Now the all-terrain vehicle, when turning, gives energy from one engine to another, that is, there is minimal consumption from the battery. One engine generates energy for the other to make a turn. And full recovery is exactly with the battery charge during descents, when the engine starts braking. Or when we release the gas pedal with a big acceleration and our car starts to slow down by inertia. Accordingly, in this case, we have a battery charge. To the battery. The battery also had to be made to order with exactly the characteristics, with the parameters that we need. That is, these are the dimensions first of all, the mass of the battery, the cells, and the capacity. In this case, we have a 72 kilowatt-hour battery here. The approximate power reserve of the electric all-terrain vehicle is from 5 hours. A lot depends on the conditions. Well, actually, as the consumption of diesel fuel, also the consumption of electricity. It depends on how you press the pedal, in what conditions, how often you turn around, at what pressure you drive, on what soil you drive. That is, from 5 hours it is a reserve of off-road traffic, which will include both descent and ascent, and a field, and mud, and a forest with a bunch of turns, and water. And water. We all experience this. Accordingly, if, for example, you just drive in a straight line, then of course the movement and the time of using the all-terrain vehicle increases significantly. Why was the electric train, the electric version, the first? Well, because there was a task to make a car for the land, for hunters, quiet, eco-friendly. For one day of hunting, that is, 5 hours of clean riding on an all-terrain vehicle is quite a lot. Ms. Han will not let you lie, that is, for hours after continuous driving, you get out, already tired from the all-terrain vehicle.
Well, it depends on the conditions, but if the road is difficult, then 4 hours is long enough. On levers, on a diesel it is.
Accordingly, yes. If people come to the hunting grounds, that is, they spend a minimum amount of time delivering themselves to the hunting place. Well, and, accordingly, back. Therefore, this, in principle, is enough for us. It is clear that if we are considering and talking about expedition all-terrain vehicles, then our next model is a hybrid or semi-hybrid, as it should be called. When we have a generator on board that will charge both the battery and power the electric motor while driving. That is, I hope that in the near future this prototype will be rolling and we will be able to show it and already tell about some characteristics. On this machine, we have worked out a fully electric transmission. That is, the hybrid will have exactly the same electric transmission as here. That's probably briefly about this all-terrain vehicle. He still has many security systems, driver assistance systems that exist. That is, it is a little difficult to tell them in one review and show them in all conditions. But we tried to make this car friendly enough. That is, any person who does not have experience of driving an all-terrain vehicle of the rotary type, when he sits at the helm, does not see any difference from the control of his car. That is, I do not know if Misha had a feeling or not, but I have a feeling that I am driving, and my front wheels are turning like a car.
There was a feeling that it was even easier to drive than a car. Well, it feels like it's easier to drive an all-terrain vehicle than to turn the steering wheel. Such an unusual likeness. Let's see what this car has under the hood. Eugene will tell us about this. Yevgeny, we are actually listening to you.
Here we look, open the lid of the rear row of passengers. Under it we have a hood space. What catches the eye, right? 2 black boxes, a fan. Well, actually everything. We don't see anything else here. We see calipers, brake discs, a piece of chains, some blue hoses and a bunch of wires. Yes? So in order. Black boxes are the cases of our controllers, that is, our brains. Inside them are brains that control one electric motor and a second electric motor. The cases are made so that they stand in regular places where these engines have regular controllers. And we have adjusted everything to the regular places. By unscrewing these 2 sealed covers, one and the second, we have access to the boards that can be replaced without removing the covers, without draining the water, because we have water cooling here, but simply by disconnecting, unscrewing the covers, disconnecting several wires, we change the boards, put new ones and let's go. That is, we always have the opportunity to purchase a controller in a spare part, so in any conditions, in case of failure, you can change any spare part. And it's much easier to do this, because it will be clean, dry and comfortable for you here. Under the controller housings, we actually have silvery electric valves. 1 and 2. Shafts diverge from them on one side and on the second side. There are brake calipers on the disc that are standing. These are mechanical brakes for the car to brake. That is, we have an electromechanical brake. That is, when we press the pedal, first we have electric braking by engines, and then at a certain moment the engine turns off and we have braking by calipers. If we look at the blue hoses on the radiator, then we have both the controller housings and the engines themselves have water cooling. The fan is turned on forcibly by automatically, upon reaching a certain temperature, which we set ourselves in the monitor that is on the steering wheel. Here, in short, we can say everything about the engine compartment that we are observing here.
So well, according to the controllers, according to the engines, more or less everything is clear in general terms. So, what do we have with the water that gets into the boat and with separate pumping of the wheels on this car?
It means that with regard to water, our boat is divided into 3 sealed compartments. The first compartment is under the feet of the passenger and the driver, where we have a pedal assembly and where we have a winch. The second compartment is a locker near the door in the conch that is located. It is also completely sealed. That is, these 2 compartments, through which, in 90% of cases, water enters the boat. This is when entering the water, when we have seals or the door is not closed, or when leaving the water, when the ass is submerged in water. They are completely hermetically separated from the central compartment in which the battery and our entire electrical part are located. Accordingly, we have a pump for pumping water in the central compartment. The pump is turned on forcibly by sensors. We have sensors displayed on the panel. That is, there are 6 sensors in the car for the presence of water in the boat. The first sensor is in the front compartment, the second is in the rear compartment, and 4 sensors are in the central compartment. That is, when this sensor is triggered, we either stop, check for water, or turn on the pump. This is, let's say, the first defense. The second defense. All the connectors, all the connections, all these covers, the connection to the engine. All this has protection from water and dust. The battery itself is completely in a sealed case, so purely from the ingress of water from flooding, we are mechanically insured here with you, and electrically it is still all embedded in the programs and in the brains of the control of the rover, that when water enters or at a critical water level, all electronics are cut off and the voltage drops until we fix the leak. As for the swap, you can observe that we have a separate swap here in front of the front axle of the rear axle with electromechanical valves. Accordingly, they are turned on approximately from the panel.
But I think this is more than an exhaustive answer. Here, in principle, according to all sorts of technical details, probably for today is all that we can tell about this all-terrain vehicle. Unfortunately, all good things come to an end sometime. Our today's rides are coming to an end. We will wait for the warm season. I want to look at the car in other conditions. That's it for me. Ms. Han was with you. The Gerasim channel is the world of all-terrain vehicles. Good mood to everyone. Bye to everyone.